Hi, in this video I'm going to make a 3D scan of this A-pillar cover, and then I will reverse it in CAD. I will modify mounting point for tweeter speaker. Okay, so there are two clips here. You see these two extended clips. If we go into this mounting hole, there's one small clip here that will slot into this hole. There's one more clip here that will go through a push pin. I can remove it if I pull it. So there are 1, 2, 3, and 4 clips for this A-pillar. Because this clip is difficult for printing, so I will print it separately in a different orientation so that it will be stronger. So all the clips will be print separately. I want to print in this vertical position so that the printer can give a smooth curve. Okay, let's get started with the 3D scanning. Now it's attached to the frame. Full screen. Should make sure that it will not fall down. Oops. Okay, let's start with the 3D scanning. I raise it up a bit so that it will be easy for me to remove. Now we use this pyramid to support it so it can be removed easily. And the 3D scanner that I'm going to use in this project is the Creality Scan Raptor Pro. I will scan this part in 22 lines blue laser without spray. I will scan the top part and then I will flip it over to make a second scan in the bottom part. Then I will merge them together in the Creality Scan software. I won't put the marker directly into the object because it's small, and I can still use the external marker to track with the object. So I will mainly use 22 lines, and if I find that I will need detailed scanning, I will switch to 7 lines. Okay, because this object doesn't contain a lot of detail, I will use 0.3 for the resolution, which is more than enough for reverse engineering. I click on scans. I will do a global marker scanning. Let me use automatic exposure. Okay. So I have about 114 markers on this board. So it's quite a lot of marker. Okay, process the point cloud. Okay, next I'm going to start the scanning with a 22 line blue laser in automatic exposure mode. Okay, next I'm going to flip this part over to the other side. I only need 3 supports. Same resolution 0.3. Click on Start. Click on Automatic Exposure. Global Marker. Click on the point cloud. Click Yes. Okay, I'll start the scan. 22 lines. .3. There's no marker to remove. Okay, here's the result. Nice and clean. We have 269,000 points. Okay, let's move to the second part, the bottom part. Process editor. Let's try manual merging. 1, 2, 3. Okay, the 3 point should be enough. Let's look correct. Click yes. Exit merging. Right, so it's complete. Next, I'm going to export this as the ASC format, and then I bring it into Cloud Compare. I import the point cloud from the Raptor Pro and also the 3D scan that I made from the car with the Raptor X, the mounting point on the door side, and then I align them together, and I can check which clips and the stiffener is required to make the design of the new A-pillar cover. See that the clips going through this slot here. This first clip and 2 more is going to a plastic slot on the door side, a rectangle extrusion. It's not necessary for this model, and also the stiffener, because I'm going to increase the thickness of this A-pillar from 2 point something millimeter to 3 millimeters, so it's gonna be thicker, so I don't need this stiffener. I don't see any obstruction. Okay, next I'm going to export this 2 point clouds into Autodesk Inventor. Okay, here's the part that has been reversed with the Autodesk Inventor and the point clouds. So in this video, I'm not going to make a step-by-step process of making this model, but I will show you the workflow and the function that I use for creating this model. First, I bring in both of the point clouds, the car side and the A-pillar cover, just to check the crashing if I want to extend some part in this model, I can turn on and turn off individual scans by using this navigator. Okay, here's a process I take to create this A pillar. So I go fast. I don't want to make this video too long. First I clear this sketch by tracing along the point cloud. I cut the point cloud into a very thin section and trace the sketch. And this will be my second sketch. I do the same. I move the plane to here and trace the line using the point cloud. So let me show you a little bit. Okay, so I trace along the thin section of the point cloud. Section is about 1 millimeter thick, and I trace the outside of the shell and offset for 3 millimeter for the thickness of the plastic shell. Okay, so I keep doing this. After I have the two cross-section sketch, I then loft it together. So this loft command in Autodesk Inventor, it can create rails. You see this line? This straight line is the rails for forcing the surface to lock into the rails. So you can create any kind of surface by just simply using this loft command. And one important thing is that with the Autodesk Inventor, the rails can be curved. This one is splined. You can add the spline for the rail, so I can loft with a curved surface like this. So it's quite easy and simple to do this with the Autodesk Inventor, but for the free CAD you can't use a curved rail, so I cannot use a free CAD to model this part using a loft command. After making the first loft, I need to trim the edge here because it's not flat. This edge has some curvature, so I need to make a few cuts. This will be my first cut. I cut it with this sketch to make its profiles. So cut it like this, and this will be my second cut. I cut it along this profiles, tracing with the point clouds. Okay, this will be my third cut. This will be my fourth cut, just to trim the bottom to make it flat. And this will be my fourth cut. It's a small curve here, so I cut it with this sketch. So now I can create the this bottom end with a 5 or 6 cut. Yeah, 6 cut to create this bottom end. And then I'm going to make a second loft. This will be my second loft. You can see here. So I made the third sketch here in this profile because it starts to curve. So I create a sketch here, and I use a curve rail. Same as before, just adjusting the curve. You can adjust by moving this. They have a small node here for moving, so you can move it in a 3 dimension. Okay, here's my third loft. Create a new sketch here. Just simply drag lines along the point cloud and offset for the thickness. And for some curvature here, I use a splined rail for lofting. So I have some spiral rail for forcing the surface to curve along the loft direction. Okay, this will be my fourth loft with this section. So I use the same curve rail. Okay, this will be my fifth loft, and the cross section will get smaller, but this wouldn't cause any issue. Loft number 7, this will be my final cross section. And if you look at here, I can create S curve for the rail so that it will fit the profiles of the A pillar cap without me making an extra cut. So I just use the S curve for the rail. Now this is all complete. All of the surface here is created by using a loft command. Okay, next step, I will create a clips. See this clip? I use a dovetail joint. Just simply using an extrusion command, create a box, fillet for the curve, and make a dovetail joint for 9 millimeters like this. This plane is cleared by snapping it onto the point cloud, so it's snapped right onto the original point of the clip. I make a mounting point for this clip. So I do this by just extruding a box onto the curved surface, and then I project the dovetail and cut it with a 0.1 millimeter gap. And I do the same for this one, creating a clips. It's quite simple, just one extrude, second cut, fillet, and a few more extrusion, and the same dovetail. Create this box and extrude it to the curved surface and cut with the profiles from the dovetail with a 0.1 mm gap. And this is the same. It's the third clips. Third clips will be pulled in the vertical direction, so I put an L shape for this clip and put the dovetail in this orientation, so when it's pulled it won't be pull out easily. So I orient the clip in this orientation. Okay, this clip is simply created by using a point cloud and trace it, and I made a cut here. See this cut, so that I can slide the clip out when I install it. So I need to make a cut here. Okay, the final clips. This is a very important clip. This one we go with into the push pin with very tight fit with the push pin, and it has to be very strong. This part I have to print this separately in this orientation on the print bed. It gives strongest layer adhesion. I decide to mount it like this. I put a dovetail into a slot like this. So now I have a final clips. Okay, for about the speaker mounting, so I'm not actually going to put a speaker there. It's just a demonstration video. So I found this drawing of the tweeter speaker. Is a 50 mm speaker, and I gave all the dimension here. What I do is that I random picking the plane and create a mounting, which is nothing complex, just an extrusion here, and then I create a hole in the center. I create a holes for inserting the brass insert. The brass insert that I'm going to use is M3. So the holes here has to be 4.4 mm wide and 6 mm deep for this brass insert. So that's it. Took me about 3 hours for making this, including the clips. It's now ready for printing. I send it to the slicer. So I start by dragging a pillar here, and then I'm going to align this to the floor print bed. But as you can see, it's not flat, so it's gonna require support for this. And then I'm going to drag the clips, all 4 clips, clip 1, clip 2, clip 3, and clip number 4. Printing clip is easy because it's just a flat profiles. This one is already correct orientation. Okay, so I will check here enable support and 3 support. I'm using the ABS for filament because it's going to be used inside of the car. It has to be heat resistant. PETG wouldn't last. Hot summer here in Thailand is gonna melt, and only filament that can be used inside of the interior of the car here is ABS. Okay, I left everything to auto except for the support. I use 3 support. Click on slice, crash. Why? Okay, I'm back again. At least it's still, I can still recover. Let's try to slice it again. This time it doesn't clash. Why it clashed the last time? I don't know. I didn't change anything. And then I send it for printing. It's 2 hours and 27 minutes. Let's check how it's print. So the first layer has a brim, which is required because there's not much of the contact point on the first layer. Okay, look like we have a constant thickness for the profiles. The good thing about the dovetail is that it's 60-degree dovetail. You can just print it without support. See here, so dovetail slot require no support, so it's very good for printing with the dovetail. This one also, see here, it's require no support, and this one also require no support. See here, because it has an open end, so it's require no support. So dovetail is very easy to print, and if your Creality is good enough, you won't need even adhesive. You just place it in. is going to be a strong press fitting. This will be a hole for brass insert. So this printing requires not much of the support, I think. And the clip is printed separately as the wall is running along the profiles, so it should be stronger. So I use the support here. So I will put the clips. Okay, this one is tight. Okay, this one. Okay, this one is also tight. Let's try this one. I made a cutout here so that I can insert this from this side. This one is a little loose, so I need adhesive. Even though I use the same tolerance, but it's a little bit loose. This one is loose. Okay, let's add some adhesive in here. Okay, I'll try this Loctite 401. Install the brass insert into this hole. I set the soldering iron to 270 degrees Celsius, and I'm going to push this in. Okay, all done. There's some edge line here, but it's very visible. And this curvature here is also smooth and tangent. Look from the outside is quite okay, except for the side that requires support. Surface quite rough, but it's going to be placed like this, so it's not visible. Let's compare it to the original part. I think it's weight about the same. Okay, first step, I'm going to insert a push pin. This here, so the push pin is in place. And next, I'm going to put in here, push the pin back in place. That's it. Okay, you can look at the seam line and the joint. Let us shut the door. So the speaker will be in this position. It should be a bit to the right. Here's your reverse engineer, a pillar cover. Thanks you guys for watching. I'll see you in the next video.